So far, we've talked about Berkeley packet filters and gone into how they can be, to some degree, infinitely flexible, albeit the syntax can get just a little bit complicated when you get into things like bit masking. Now we're going to switch gears and talk about Wireshark display filters, which are a little bit different both in their flexibility, how they're used, and simply in the fact that they're limited exclusively to Wireshark and T-Shark. And the reason for this is that these display filters are based upon dissected fields from the protocols. So I've mentioned that Wireshark is able to read all these different protocols, but because it has dissectors for each one of them. And it's also these dissectors that break these things into fields that allow you to do these filters on them. So whereas a Berkeley packet filter is going to be, at least without bit masking, is going to be limited to a few specific things like ports and protocols and whatnot, you can get quite specific with Wireshark display filters, which means you can also get into filtering based upon application layer protocols. So for instance, the display filter on the screen here shows you some things that you could do potentially with a BPF, but it would be very difficult to come up with that, and it would be a pretty darn complicated filter. Whereas here, if we wanted to filter based upon the SMTP authentication username of Chris, that would be really easy to do, right? And you can kind of even see some structure starting to form. You can see we have the protocol on the left, we have a couple of layers of field names within that, and then we're matching based upon the value Chris. So that's pretty self-explanatory, pretty easily readable. We'll get into the structure here in a minute, but nonetheless, that's pretty nice little compact way to do that filtering, which is pretty neat. Now, the key thing here is that whereas BPFs within Wireshark are used to filter packets as you're capturing them, display filters are really used to filter them after they've already been captured. So we have the little filter bar on the top of the Wireshark screen, which we'll look at here in a minute, and you can input those to filter what you've already captured. There's certainly benefits to filtering after you've captured. The worst thing in the world is when you apply a capture filter and then you realize that some of the packets that you filtered out were things you actually might need. So this gives you the ability to capture everything and post-filter later. In some cases, you might be forced to do filtering after the fact, after capture has occurred, maybe like in an NSM scenario. So this is a little bit more flexible in that way. You may notice we've used display filters multiple times already in some of the other modules just to limit the number of packets we've seen. So you may already be at least somewhat familiar with that, but I do want to get into some of the structure and what that syntax looks like, and also show you a whole bunch of different examples of helpful Wireshark display filters. As you may have observed in the last example I just showed, the syntax for Wireshark display filters is actually pretty straightforward and pretty easy to follow. You just have to remember that it exists in a hierarchy. So that means there's levels in the structure that makes up these protocol filters. And that's really going to take the form of protocol.field.subfield. So you start on the left with the protocol you want to filter based upon, so very similar to capture filters. And then you're going to specify the field that's pulled out via the Wireshark dissectors. And then if there's a subfield, if you want to go a little deeper, you go deeper in that way by just appending it with another period. So most of your filters are going to take this structure. Some will be very simple, some will be a bit longer, but they're pretty much all going to conform to this type of standard. Now let's actually go through an example here so you can see what I mean. Let's say, really simply, we just want to filter all TCP packets. We just want to see all of those. That's its own protocol, of course, so we can just start with that very simply and just say TCP, and that will show us all TCP packets. It'll filter and match any of those. Now let's say we want to get a little bit more specific. We want to filter on TCP flags. We want any TCP packet with flags enabled. Now, we know that's going to be pretty much all TCP packets in this case, but we still want to filter on TCP flags, which is a field within the TCP protocol. To filter on that, we simply use tcp.flags, and that'll give us any TCP packet with flags enabled. Now, that's not a super useful filter right there. It's not one we're really going to use, but we can make it into a useful one by adding to it and saying that we want to filter based upon all TCP packets where the SYN flag is set. Remember, that's an example we looked at when we looked at capture filters. To do that, we're going to specify the subfield in this case, and we end up with tcp.flags.syn, and then we're doing a comparison operator here, and we're just saying equals 1, which is basically saying that bit is on or enabled, and we'll be filtering and matching on any TCP packet with the SYN flag or bit enabled. So you see what we're doing there? TCP is the protocol, flags is the field, and SYN is the subfield in this case. Now, the nomenclature of field versus subfield may be a little weird because the SYN flag is its own field to some degree, but it is a property of the greater flags concept. So that might be a little confusing to you, but once you dig into more of these, you'll get it and you'll start to see this relationship and how it exists. Let's look at one more example here. Let's say we want to show all HTTP traffic. HTTP is a protocol, of course, so we can just type HTTP, and that will show us all of the matching HTTP packets in the capture. Now, say we're only concerned about requests from the client to the server. We want to see all HTTP requests. Request is a field type, so to speak. So we're just going to do http.request, and that's going to show us every request. So it's going to show us gets, posts, heads, any type of HTTP request will be shown when we apply this filter. So this is a pretty useful one. I use HTTP request a lot, but let's take it just a little bit further and say we want to use that to show only HTTP GET requests. So the GET request is actually called an HTTP method, so it's part of the method. These are method types. So we would say http.request.method equals GET, and this will show us all packets that are HTTP GET requests or using the GET method. So you see here again, we have this hierarchy where we have protocol, field, subfield. The key thing you have to know is you obviously have to understand a little bit about the specific fields you want to filter on. You want to understand what the proper nomenclature is. If you called, in our TCP example, if you called the SYN bit a bit instead of a flag, you didn't know it was called a flag, you might not necessarily be able to find that filter super easily. If you call a GET request just that, if you call it a GET request rather than the GET method, you might be confused and not be able to quite understand why it's not working. So you have to be able to know the nomenclature and the proper field names within these packets. Fortunately, Wireshark makes it easy for us to kind of explore and figure these things out. It has some nice autocomplete features and a nice little expression builder that we'll get to in a little bit. So don't fret too much on that. You'll figure that out as you go along. And you can also build filters from existing packets, which we've talked about a little bit already, and we'll talk about some more later. So don't worry about this too much. As long as you understand that this hierarchy structure exists and you're doing this thing where you're starting with protocol and adding fields and subfields, the rest of it will kind of follow. But you do need to understand that the hierarchy exists here. Now, a key takeaway when dealing with display filters is how things match and how we negate matches. So how we tell it to show or hide specific things. For example, if I just put in http.request.method, that's going to be a match. It's going to show me every packet that contains the field http request.method, regardless of what the value is. So I'm going to get post, gets, heads, all the methods are going to be matched there. So it's just saying if that field exists within a packet and has a value, go ahead and match it and show it to me. So that's important to recognize. It's going to match everything even without saying, HTTP request method equals get, right? It's going to show everything. Now, we can negate that as well. So I can say http.request.method, and that's going to show me every packet that does not have that field present. So it's going to go ahead and get rid of every GET request, every POST request, so on and so forth. So it's going to do a straight negation there just for the existence of a value in that field. Now, we also have the ability to do comparisons like we've done in some other examples already, and those are probably the things that you're probably most familiar with. So for a comparison, we're going to say http.request.method equals get, and that's going to match every HTTP packet where the request method equals get. So we're actually doing a comparison there. It's an equals comparison, but we can do a lot of other comparisons as well. And this table kind of overlays the different ones you can do. So these are pretty much your standard comparison operators that you're going to see across most programming languages and everything else, right? The syntax may be a little bit different, and notice that there's two ways to do every one. So we have equal to, and we can do two equal signs, or we can just do EQ. So two different ways to do that. You'll see that different people do it different ways. Greater than can be the greater than symbol itself, or just GT, for instance. I tend to stick with the column on the left, so the actual symbols, just because that's a little bit more familiar in terms of programming and coding, and that's something you're going to be using elsewhere, whereas EQ and NEQ and GT and LT and so on are a little bit Wireshark specific. Maybe easier to read, and ultimately it doesn't matter what you use. Use whatever you're most comfortable with, but also try to use something at least somewhat consistent with what everyone else in your organization is using, so you can have that shared comfort in what you're all using, and easier to read from a group perspective that way. Now, we also have the concatenation operators, and those are the ones you would expect as well, right? So we have and or. So an and would say that both conditions must be true, and or says that either condition should be true. But we also have a unique one here that we haven't looked at yet, and that's XOR. Identified by the two caret symbols or the up arrows there, and that basically says one and only one condition can be true. So that's a very specific use case, but that is available. And of course, we have the negation operator, which we've talked about, which says not or not true if we want to match packets where something does not exist or is not true. So we have all these different operators we can work with. You'll see these as we go through a bunch of the examples moving forward. Now that we understand the syntax of Wireshark display filters, I want to go through a bunch of example expressions that you might want to use in your captures. And just like we did with capture filters and BPFs, I'm going to tell you the scenario I want to match. And instead of just giving it to you immediately, I want you to pause the video and think about it, and maybe have Wireshark open in another window and work through it yourself and see if you can figure out what the filter would be. So let's go ahead and jump into that. And we'll start with a simple one. It's an example we've already actually covered. And we'll say that I want to match all HTTP traffic. I only want to see HTTP packets in my window. How would I create a filter that would match that? In this case, this is a pretty straightforward one. HTTP is just a protocol, and protocol is kind of at the top of that hierarchy we talked about. So to match HTTP traffic, I'm just going to type HTTP. Pretty straightforward. Let's do another one that's kind of similar, but let's say we want to exclude a particular type of traffic. So we don't want to see any RDP, remote desktop protocol traffic. We want to hide all of that from view. How would we create a filter that lets us do that? For this one, again, we're going to use the protocol name, but we actually want to hide the traffic. We don't want to show it. So we're going to use the negation operator here. So the exclamation point RDP is going to hide all RDP traffic. It's going to match anything that is not an RDP packet based upon what the dissector detects. Now, there's also another way to do this too. We don't have to rely on the RDP dissector in that way. We can also rely on the port. If you know what port a service commonly uses, you can actually filter it that way as well. And you can do something like this, where you have the negation operator again, and we say TCP.port equals 3389, which is the standard port for RDP traffic. Granted, this isn't always the best way to do it, because you can have RDP traffic that goes across a different port, and that's true of any protocol. Many of them will be associated with a particular port number, but that doesn't mean they have to go over that port number. So this second scenario isn't probably the best way to do this, but it is a way to do it, and I did want to show you that you do have that option. Another similar one, how would we create a filter that is going to hide all ARP traffic? It's going to match anything that is not an ARP packet. If you got the last one, you should get this one, right? Exclamation point ARP is going to negate any ARP traffic and hide that from view. Next, and the last one on this slide, are TCP send flag set. So for all TCP packets, I only want to see things that have the send flag set. Again, we've already covered this scenario, so if you want to, you can look back at that, but try to work it out for yourself in case you forgot it and see if you can get to the answer. In this case, the answer is tcp.flags.send equals 1. So we have that hierarchy present again. We have protocol, field, subfield, and then our comparison operator, and we're looking for a value of 1, so we're looking for that flag to be set. Next, let's try another example. In this case, we're going to get a little more involved here, a little more detailed. I actually want all IP packets where the TTL value is smaller than or equal to 128. So I'm looking for anything that's generated that has a TTL of less than 128. So what would that filter look like? This one sounds a little complicated, but it's not too bad actually. We're going to start with the IP protocol. So we list that out first. And TTL is just a single field within the IP protocol. So we have IP.TTL, and we want smaller than or equal to, or as it's otherwise known, less than or equal to. So we use the less than or equal to operator, and we put the number 128. And this will match any packet whose TTL value in the IP header is less than or equal to 128. So pretty straightforward. It sounds a little more complex than it is in the description, but not too bad. Next up, I want to match any packet that is either telnet or FTP traffic. I'm fine with either one of them. It doesn't have to be both. That would make a lot of sense, but any packet that is either one of those two things. So what would that filter look like? For this one, we're going to specify the names of the protocols again. These are their own protocols, and again, that's the highest level of that hierarchy, and we're going to combine those with the OR concatenation operator. We can actually use the text OR, but in this case, I like to use the symbols, so I use the two pipe symbols, which indicate OR. So this is saying match anything that is telnet or FTP, and any of those two protocols will show up once this filter is applied. Now, this is another one similar to a previous example where we can also match based upon port. Telnet uses port 23, FTP uses port 21. So we could also do something like this, where we say TCP.port equals 23 or TCP port equals 21. Again, this isn't the most recommended thing because these protocols can run on different ports and oftentimes do. But I do want to show you this is an option that you can work with. Okay, let's try another one. Show me all email traffic. That's kind of broad, but think that through. And how would you show all email traffic in a Wireshark capture filter? So for this one, email is not a protocol, right? There's no email protocol per se, but there are protocols that support email. And to do this one, you really have to know what protocols you're expecting to some degree, or just list out all of the common mail protocols. For this example, there are really three that are the most prevalent and most common in the world that I would think of if I wanted to show all email traffic. Those are going to be SMTP, POP, and IMAP. We'll talk about a few of these protocols in depth later. But to do this, I can simply list out the protocols and combine them with OR concatenation operators. So SMTP or POP or IMAP. In this case, I actually used the word OR. I could have used the double pipes as well, but I wanted to mix it up a little bit. So this is a good example of having a real world use case. Okay, I want to see all email traffic. And then breaking that down into protocols and then converting that into a filter. The filter itself is pretty simple, and it shows that Wireshark makes this really easily with the protocol dissectors that allow you just to use these simple protocol names. Okay, let's do one more here. And in this case, I want to see all TCP DNS traffic to or from 8.8.8.8. DNS, of course, is primarily a UDP protocol, but it can be TCP in some specific use cases that we'll talk about later. So how would I create a filter that shows me all TCP DNS traffic to 8.8.8.8? This one's going to be a little bit more complicated than some of the ones we've done already, but you just have to break it into its component parts, and it isn't too crazy. So I want to see all TCP DNS traffic, which means the traffic has to be TCP and DNS, and I also want it going to 8.8.8.8. So we know we're using ands here. It has to match all of these conditions. And then we just simply string together the individual conditions or the individual clauses here, and we end up with something like this. In this case, we say TCP and DNS and IP.address equals 8.8.8.8. So while it sounds complicated, it sounds like there are a lot of conditions we're matching. When you write it out, it's actually not that bad. And you'll get to the point where you start, as I mentioned with capture filters, you almost start talking in filter speak. You'll say things in the way they might be written out as filters, and that's actually a good thing. That's going to help you along. So even complex filters like this are not too incredibly crazy to write up. Now, you may be saying to yourself, okay, Chris, when do we get to the really hard ones? When do we get to the crazy stuff like we did with capture filters with bit masking and multiple byte fields and all that stuff? And you may actually be surprised to know that things aren't really going to get any more complicated than what we have on the screen here. These clauses can get much bigger, and I've seen people write Wireshark display filters that are several lines long, and you get to the point where maybe you're grouping things a little bit with parentheses when you're talking about order of operations. But for the most part, things don't really get any more complicated than this. The good thing about Wireshark display filters is they're limited to the protocol dissectors and the fields that are pulled out. So you're doing everything based upon fields that are being examined. That's the good thing because it makes things a lot easier. It's also the bad thing in the limitation, because if Wireshark has a protocol dissector and it's not pulling out a field you need to examine, filtering based upon that with the display filter is very hard or impossible in most cases, and you have to get a little more creative and maybe switch over to capture filters or do something else there, or maybe even edit the code and write your own part of that dissector that will let you do what you need to do. So keep that in mind. With simplicity comes limitation, and that's kind of the case here with Wireshark display filter. There is a little bit of limitation. But that said, for day-to-day analysis, and unless you're using a bunch of custom protocols, I rarely ever encounter a scenario where I can't filter with Wireshark display filters on the things that I need to filter on. So that's not really a limitation I encounter a lot, and I do a lot of packet analysis. So keep that in mind. You're really not going to run into those limitations again unless you're using a lot of custom protocols or maybe analyzing a lot of malware that's using custom protocols or things of that nature. But when that happens, we do have the ability to use capture filters and BPFs both inside of Wireshark when we're doing the capture or outside of it when we're using other tools. But nonetheless, things don't get much more complicated than this, which is one of the reasons why display filters are really enjoyable to use when you need to filter down packets.